All right, looking at continuing the review for Unit 5 in Math 1. We're looking at exponential stuff here. So we're looking at a population of endangered fish decreases exponentially and can be represented by the function f of x equals 1,200.93 to the x. What is the percent of rate of decay? And so it's decreasing. Okay, the decay rate is 7% because we're subtracting that from the 1. So 1 minus 0.3 is going to come out to 0.07. Okay, and that's where we get our 7%. That was number 7. Number 8. Determine if there's real solutions, no solutions, or infinitely many. So I get 8 to the x equals 64. So I'm going to solve these. And the question is, can I make the bases the same? Yeah, and if I can, hey, this works. X equals 2. Okay, so there's one real solution for that one. Okay, the next one is 2 to the x equals -9. Well, I cannot put a number up in this power that's going to make this negative. Because like if I plug in like -2, that doesn't give me -4. It gives me positive 1 over 2 to the 2, or 1/4. Okay, so I cannot get a negative out of that. So that is no real solution. And the last one for our next one for number 8 is 7 to the 2x equals 49 to the x. So if I try to make the bases the same here, I would realize that 49 is the same as 7 squared. Okay, and here I would multiply these powers together. Okay, and so if I have the exact same thing equal each other, that is an infinitely many solutions right there. Infinitely many solutions. Okay. Moving on to number 9. State where there's a mistake here. So it looks like, so if I go 3 to the 2x plus 1 equals 1 over 2,187. And if I work that out, I can mess around with it on my calculator a little bit. Oops, sorry. Well, that came out not so good. This equals 3 to the -7. Then I would set those powers equal to each other. Squeeze that over here. That would be 2x plus 1 equals -7. And if you look at the answer, the question, they have it set equal to a +7. So that's where the mistake occurs. So the answer is, where does it make a mistake? And it's at step 2. Okay. Looking at number 10, they give you this, -2 to the x equals 10. And then they give you the graph. Okay, so you got one line up here. You got another one going like this. Okay. They want to know, where's the solution? Well, if I graph them, the solution is where they cross. So you can see how these lines are not going to cross. So there is no solution. The lines don't cross, there is no solution. Okay. Let's write the explicit formula. So I get, this is number 11, 4 8, 16, 32. And just to remind, our explicit formula is A of n equals A of 1 r to the n minus 1. Okay. So I need to figure out what the r value is. You always take that by doing, a sub 2 or a of 2 over a of 1, or the right one over the left one. So r is equal to 8 over 4. R is equal to 2. I need to know my first term, which is a of 1. That's a 4. So the explicit formula is a of n equals 4. I like to put the r in parentheses to the n minus 1. Okay. So let's do one more problem.
Baby and China, please report to student services. Baby and China, please report to student services.
All right, try to ignore that all call right there. So here's another one here. So now you can see it's decreasing. So I'm already aware that my r should be negative. Sorry, not negative. Our r should be less than 1 because it is decreasing. You see the numbers are getting smaller. And so we got to find our first term, which is 54. We have to find r. I always take the right one on top of the left one. Okay, in this case, it probably would be easier to take some of these smaller numbers and do it because it doesn't matter which two you can see. Oh, yeah. Oops, it's going to just be 1/3. Okay. 1/3. So now I'm going to plug it into my formula. A of n equals 54 times 1/3 to the n minus 1.